Hello everybody. So we are gonna start with the functions that perform the integration in Matlab, and we're gonna start with just a quick revision on the strategies that we can follow when we go for integration. So we have one of two paths, either to go for the analytical integration or to go for the numerical integration. So Matlab gives the user a lot of options, so you can go for this or this, and for each one of them you have some options. So we are going to talk about two functions that can do the analytical integration, which is the int function, which is what we're going to talk about today, and the dsol function, which is going to be the topic of the next video, inshallah. For the numerical integration, we are going to cover two functions: the traps function, which does the kind of something that we did a lot in some applications of chemical engineering, which is getting the integration as the area under the curve. So this is what the trubs function does, and the ODE function, and this is actually for me the most important one of them, because this is more powerful than the three of them. It can work for different systems, can solve more than one equation simultaneously. So that's why this is gonna be kind of focus. We're gonna focus more on this than the other three. The other three are useful for cases, of course. I'm not saying that they're not useful, but this is the at least for me, the one that I use more than these. So the int function, before we go ahead and see what the int function does, I'm gonna go quickly through some examples for the integration and the analytical integration. And again, we mentioned this in the previous video, and I'm just going quickly through what the analytical integration is. So it's just doing some mathematical operations, which we call the integration, to convert a differential equation into an algebraic equation. And of course, if you took any algebra courses before, you would be familiar with the rules and the steps that you would follow for different types of equations, and it's kind of long topic. So I'm not gonna go through the rules of integration, of course, but I'm just gonna go through some examples to be kind of refreshment and to point out some things that I want to highlight. So first, for if a very simple case like this, if this is the function which is f of x, you do differentiation, then you multiply this by this and subtract 1 from the power, multiply this by this, you end up with the 6, and then subtract 1 from the power. So this is what the f dash would be. And if you're gonna do the integration, so it's gonna be the opposite. I'm gonna add 1 to the power and divide by the new power, so it's gonna be x power 5 divided by 5, and then x power 2 divided by 2, and then you should add a constant here, which is the constant of integration, using the initial conditions, or if you have definite integration, you have limits of integration, then you can you don't need to calculate this c. Or I mean, you can get the value of this c. So this is the first example. The second example is a function that is has an argument that is another function. So it's like the exponential has an argument of x power 3. So it's a function in a function. So to do the differentiation, you would know that the differentiation of this is going to be the exponential. It's the same thing, so it doesn't matter. Whatever what you have inside is going to be exponential of x power 3, but you have to do the differentiation of what's inside the function, so it's going to be 3x squared. So when you do the integration, you must make sure that to get it back to x power 3, that this is multiplied by this. You have the differentiation of what's inside here, and again you would have a constant here. But and this is one tricky part of the integration. It's like when you think of the exponential of x power 3, which should look like an easy function. It's not like a very big function, but you would find that this is a very, very complex integration, because you don't have 3x power 2 multiplied by so this is one point that we're gonna cover. One other thing that we would cover today also is the multiple integrals. So you have here double integrals. The function is a function of x and y, and you do the integration um, with respect to x and then with respect to y. So what we do is we take the inner integral and we do the integration, and we do the integration with respect to x, and we consider y as a constant. So what we would do is to it's getting this x power 2 divided by 2 multiplied by y, it's like a constant, and this is x power 3 divided by 3y plus c, and then do the second integral with respect to y, and the same thing, we would consider x as a constant and then do the integration with respect to y, and this is what we will end up with after doing the integration. Again, you have here two constants because you have the double integral. So the first constant for x and the second is for y. So all these kind of equation we can do using the int function, which is a very nice thing. Actually, you can do integrations without going through all the steps, and of course you remember there were some very time consuming integrations that you have solved before, and you can compare what we did before to what we can see here. So the function that we're going to use, again, it's called int function. So int s is it gives you the indefinite integral of s with respect to its symbolic variable. The symbolic variable, we mean the x or y, what we mentioned in the previous examples. And if you want to define this, you would, or the variable, you would put it as the second input to the function. So it's going to be s and v, so it's integral of s with respect to v. You can define this function s as a function handle or a symbol. And this is the first time I think we would talk about these symbols, and this is why we need it here. And we need to define the independent variable as a symbol. This is one other kind of input that you can put to or define to Matlab, which is using the sims, which putting symbols. So you are defining sims and x, which means that Matlab will deal with x as a symbol. It's not as a matrix, it's not as a logical expression, it's just as a symbol. Because the output of this is going to be a symbol, it's going to be an expression, the mathematical expression. So you have to have a symbol here that would be used to produce a symbol. So for instance, if you want to do the integration of x, so this is what you would do. You cannot just put it as x without the at x thing. So you can do this. So this is the first part, which is the s, and this is the second part, which is the v, and we did the sims x before or first, and then the answer will be x power 2 divided by 2. So now let's go to Matlab and see what we have here. So let's I will try some examples. I'm sorry, I wanted to open the notes first, so that we would just check what some of the examples here. So this is what I just mentioned here, the integrations, and this is the syntax that we used. And then let's see some examples. Let's see, this f is 1 over x divided by ln x. So to do this, I would first do sims x. So now I defined x as a symbol, and this is what you would see. It's 1 by 1 sim, which is a symbol, and this is an input which is kind of new to us. And then what we will do is we can call it h, for instance. It is the int, which is the integration of the function that it says here symbol object or whatever thing. You can put it as a function handle, as I said. So you can put it as at x 1 divided by x divided by log x, and this is with respect to with respect to x. So it's giving you the len, which is log x, which is len of len x. And if you do it by hand, you'd see that len of anything, the integration of this is going to be 1 divided by this thing, so it's going to be 1 by len x, and you would multiply it by the differentiation of the len x, which is 1 over x. So this is what you would end up having here. We can see another example. It's 1 divided by x power 2 minus 8. So let's call it g equals the integration of. I just wanna yeah, this is what I meant. You can put it as this or as this, and let's, before going to the other example, we can remove this function handle and it still works, so you don't need to put it as a function handle. And now let's go to the other example. It's the integration of, we said x power 2 minus 8. It is x power 2 minus 8 with respect to x, and it's giving you x multiplied by x. You'd see that this function kind of looks not very nice to see. So there is another function which is called pretty, and this pretty just puts the function as it's not very pretty, but it just puts the function as in a way that's easier for you to understand, instead of having all these brackets. So it's x multiplied by x power 2 minus 24 divided by 3. And now let's see the example that we just mentioned before in the slides, which is j, for instance. It's the integration of exponential of 3 multiplied by x power 2 with respect to x. And again, I said this might seem like a simple integration, but because it's not multiplied by the differentiation of what's inside the function, you'd see that this is kind of a very weird function, and you'd see that there is an error function, which is something very not easy to deal with, or it's not very trivial. And you see that there is I here, which is, I think it's the square root of -1, if I understand right. But I mean this is what you will get of the integration of exponential of 3x squared. You can make it even more difficult and see how yeah, in a case like this, you see that integration of exponential 3x power 3 is, he couldn't find an answer to it. He just put it as it is. So again, you could see that the integration is not that easy thing, and you could find that the process would be very complex. There is one important note that you should have noticed, is that for all the integration that we did, you didn't see any constant of integration. It was not shown in any of these cases, and this is one point which is important to note, that the end function does not put the constant of integration like what we've said here. Again, it's just a symbolic integration that does not take into consideration the constants. Let's see one more example of the double integrals, which is h, which is xy plus x power 2 divided by y. So it's gonna be int. So I have to define now two variables, which is x and y, because I have the differentiation with respect, or integration with respect to x and y, and I would call it m, which is going to be double integral. So it's going to be two integrations. It's going to be x multiplied by y, x multiplied by y plus x power 2 divided by y, and this is first with respect to x, and this is I'm sorry, this is with respect to x, and this is with respect to y. So this is the inner integration, which is dx, and then everything is going to be integrated with respect to y. Let's make it pretty. So it's going to be x squared y squared divided by 4 plus x power 3 log y, or which is ln y divided by 3i, which is exactly what we saw here. It's x squared plus y squared, or multiplied by y squared divided by 4 plus x power 3 divided by 3. So this is exactly the same output. So you can do double, triple, any number of multiple integrals that you are interested in. Again, there is no integration constant here, as we mentioned in the previous example. So if you need it, you can do it by yourself. One last example that we want to just cover to see some limitations of this function, which is this integration. So in this case, you would see that for all the cases before, you had the function on one side and all the variables on the other side. Here you have x and y, and previously you would have a function of x and everything in x is on the other side. So it is this is how the type of functions that we use. But in some other cases, you would see that you have cases like this. you have dy by dx, so you have the two variables here, and the two variables are also available or shown on the other side. And what we know that to do this, you have to do separation of variables first. You have to get y on one side and x on the other side, and then do the integration. Int function cannot do this. Int function only works if you have function equals integration of this function with respect to x to y, dx, dy, whatever. But in a case like this, int function cannot deal with it. And there are other functions that we will talk about later that can do this thing. So this is what we want to cover in this video, and in the next video you'll see some other function, which is the desolve, that can do more, will have more options than the end function. So I'll see you then, inshallah. Goodbye.